In this video, we want to discover some measures of central tendency. So what is central tendency? Well, that's the extent to which the values of a numerical variable group around a typical or central value. And there's actually several different ways we can try to describe this kind of a phenomenon. And we're going to look at 3 of those ways in this first video. And they're all something that you're probably very familiar with, such as this first one, which is the mean, which is also called the arithmetic mean, or the average. Well, what is the arithmetic mean here? Well, that is notated by x bar, so a little bar over this x. This x represents our set of variables, set of values. So the arithmetic mean is the sum of all values in this set, all divided by the number of values or items in this set. And that's our arithmetic mean. For example, if there are n values and x1, x2, all the way up through xn are these values, then the mean is x bar is equal to x1 plus x2 plus all the way up through x sub n divided by n, right? All of our values divided by the number of them. Before we do an example, I would like to discuss something called the summation symbol. So let's write out what that is, because that's going to give us a nicer way to write out this above formula, and it's something that we will see in several other formulas throughout the rest of the semester. So let's go ahead and introduce this now. So our summation symbol is a capital Greek sigma, and if I write something like I equals 1 down here up to, let's say, 7 up at the top, what this means is this symbol here means we take the sum of I as I ranges from 1 to 7. This means we go 1, and then we write the next one. We put a plus here, and we write the next set. Well, I iterates up by 1, so this becomes 2, plus, and then we do the next one, which is 3, and we do this until we get to 7. And so if we see a summation symbol, and it's the summation on this function I, as I goes from 1 to 7, that just means 1 plus 2 plus 3 plus 4 plus 5, all the way up through 7. So in particular, how can we rewrite x1 plus x2 plus all the way up through x sub n? Well, we can write this as the summation from I equals 1 to n of x sub I. Right? We say I is 1 first, so we get x sub 1. We write that out. And then we have our summation symbol, so that means add the next one. So I iterates up to 2, so this is now x sub 2. We add that. And then I iterates up again to 3, and then we add x sub 3. And we do this until we get to the value n. So this right here is our summation symbol. This capital sigma, and this is our notation given some function here on I, on the variable I. All right, so what does this all mean? Well, this means that we can rewrite our mean, our average, as the summation from I equals 1 to n of x sub I, all divided by n. And so this is our formula for the average, also known as the mean, or the arithmetic mean. In particular, we're using the terminology arithmetic mean to be something different than a geometric mean, which we'll actually discuss in the next video. But this video, we still have several things that we want to look at. So one thing I want to look at now is a quick example of finding the arithmetic mean. So let's suppose we have data that looks like this. Let's do 17, 20, 23, 18, 20, 22. So if we have something like this, I want to first calculate the mean. A lot of times, especially for some stuff we're going to calculate in just a moment, a lot of times it might be best to go ahead and put this into an ordered array. So we can order this data as 17, 18, 20, 20, 22, 23. That's not really necessary to calculate the mean, but it's usually a good thing to do with your data anyways. So let's see an example here. So we're going to calculate our mean. And this looks like 17 plus 18 plus 20 plus 20 plus 22 plus 23 all over 6, because there are 6 data points here. All right, 17 and 23 together is 40. 18 and 22 together is 40, and then 20 and 20 is 40, so we get 43 times, it's 120 divided by 6 equals 20, so we get an average or a mean or an arithmetic mean of 20 here in this example. So pretty straightforward. But what I wanted to show you with this is that one reason the mean may not always be a great idea of or a good choice of the central tendency that we should be following is that extreme values have a high chance, or they do, adjust the mean quite a bit. So it can throw off the average by quite a bit. So if this data just had 1 point different, for example, if our data was 17, 18, 20, 22, 23. If one of these 20s was maybe like 78, then what is our new mean? Well, we get 17, 18, oh, sorry, oops. Supposed to be plus symbols in there. 17 plus 18 plus 20 plus 22 plus 23 plus 78, all divided by 6. All right, 17 and 23 is 40. We get another 40 there, so it's 80 plus 20 is 100. Plus 78 is 178. Now we divide that by 6. And that value is 33, it looks like. So we see that by changing one value, and if there's some extreme value here, this gets changed by quite a bit. Our average gets changed by quite a bit, from 20 to 33. So, notice from that maybe the mean or the average or the arithmetic mean is not always the greatest choice for a measure of central tendency. So let's talk about 2 others real quick. The second type of central tendency that we're going to look at is the median. the median is the middle number in an ordered array. So for example, well, actually we should say something first. If the ordered array has an odd number of values, the median is the middle number. If the ordered array, no, the word array I missed. If the ordered array has an even number of values, the median is the average of the two middle numbers. So for example, earlier our set of data points was 17, 20, 17, I wanted this in an ordered array, 17, 18, 20, 20, 22, 23. And if we look at our middle numbers, those are 20 and 20, right? We have an even number here, so we need the average of the two middle numbers. So those happen to both be 20. So the median is 20. Now, let's look at the other set of data that we had, right? We had 17, 18, 20, 22, 23, 78. So if we had an extreme value here, what are our two middle numbers? Our two middle numbers are 20 and 22. We have an even number of these, so we take the average of these two middle numbers. So here the median is 21. So notice that the extreme value did not change the median by nearly as much as the mean. So in this case, where there are extreme values, perhaps the median is a better idea of where the center of our data is, relative to the mean. There is only one more type that we'd like to talk about, and that is the mode. And this is the value that appears most often. If all values appear equally often, then there is no mode. Okay. So real quick, let's look at our previous example. We had the values 17, 18, 20, 20, 22, 23. So in this case, we have 17 showing up once, 18 once, 20 twice, 22 once, and 23 once. So our mode is 20 for this set of data. And that's it for this video.